Hello, welcome back. Today we're going to talk about something absolutely amazing. Today we're going to discuss the phases of the moon, but not only what they're called, we want to talk about exactly how they happen. So that when you look up in the sky and you see the different phases of the moon, in your mind you have a mental picture as to exactly how that is happening. Now, the very simple explanation that we all know is that the sun is illuminating all directions of space. It's illuminating the moon, and we see the moon illuminated, and that causes the phases of the moon. But we want to go a level deeper than that to understand exactly how it happens. All right, now here we have a time-lapse movie showing the phases of the moon over the course of a lunar orbit. We start at a new moon where the moon is not visible, and then we see the illuminated part of the moon getting larger and larger. We call that waxing. Eventually it reaches a full moon, which is what we see, the fully illuminated moon, and then the illuminated part gets smaller and smaller, which we call waning, and then eventually it gets back to a new moon. This is what we want to try to understand. Why does it follow this pattern? How does it work? All right, now to do this properly, I have a bunch of pictures and also I have some props to show you exactly how it happens. Here is a similar to what we just saw in the video there. We start with what's really not on this picture, with the new moon. That's when the moon appears completely darkened. And as time goes on around the month, this is one lunar orbit going all the way around, we see more and more and more of the moon illuminated, reaching a full moon, and then we see less and less and less of the moon illuminated, and then we get back to a new moon again. So this over here we call, of course, a crescent moon. We'll talk about the word waxing in a minute. It's called a crescent moon. And then on the other side, we also have another crescent moon. So these are sort of mirror images of each other. They're both crescent moons, right? We have the full moon in the center, and then we have first quarter and third quarter. We'll talk about why it's a quarter in a second. It appears to be a half moon. The reason we call it a quarter is just because it's a quarter of the way through the cycle. And then this will be halfway through the cycle. And this is the next quarter of the way through the cycle. And then we get all the way through it there. And then we have this term called gibbous. Right? This term, when you see the two gibbous terms, this is when about 3/4 of the moon is illuminated, essentially. So we start with a very thin crescent, and then about half of the moon is illuminated, and then about 3/4 of the moon is illuminated, and then the full moon is illuminated, and then back down to 3/4, and then back down to about a half of it, and then back down to another sliver. So crescent, crescent, quarter, quarter, gibbous, gibbous, full. Now, the word waxing means to get bigger. The word waning means to get smaller. So now we can put it all together. We have a waxing crescent. That means a crescent which is getting larger each day. As the moon, as we go through the day-night cycles, every time you look at the moon on subsequent days, it's more and more and more illuminated, so it's getting bigger. That's what the word waxing means. Then we get to this first quarter moon here. Then we have the gibbous phase where it's mostly illuminated, again getting bigger and bigger. Waxing means getting more and more and more illuminated. We reach full illumination, we call it the full moon. And then we have the word waning. Waning means to get smaller. So we have waning gibbous, which means mostly illuminating, but getting smaller, smaller, smaller to the waning crescent. So the word waxing in your mind, you need to be thinking becoming more and more and more illuminated. The word waning, you need to be thinking getting less and less and less illuminated. That's how it works. All right, these are the phases of the moon. This is what we seek to understand. Now, let me tell you the number one secret you need to understand in order to really, really get a deep understanding of the phases of the moon, right? And that is that your mental image of our Earth-Moon system, along with the sun, is most certainly wrong. It was wrong for me. It's wrong for everybody because we don't have a good way of measuring large distances in our mind. Let me show you what I mean. If I ask you to draw a picture on a piece of paper to scale of the Earth and the moon, what do you think most people would draw? Most people would probably draw the Earth, like a big ball here, something like this. And they would probably go over here and they draw the moon, something like this. Something relatively similar in size to Earth, a little bit smaller, not too far away. This is one Earth diameter, another Earth diameter. I don't know, maybe put the moon here, maybe put it here, but just a few Earth diameters away. This is completely wrong. The scale in our mind is totally wrong for how big the Earth and the moon is and also how far separated it is. Once you understand the scale, then you can very easily understand the phases of the moon. Let me show you what a real scale drawing is. This is an actual scale drawing. This little bitty marble right here, this little blue area, this is the Earth to scale. And then way over here is a tiny, tiny dot. You can almost not even see it. And to scale, this is how far away it would be. Now, in real distance units, The moon is about 384,000 kilometers away. 384,400 to be exact. Now, of course, it's not a fixed number. The orbit of the moon is really elliptical, and so it gets a little bit closer and a little bit farther away from the Earth over its orbit, but we can just say that that's the average distance between the Earth and the moon, 384,400 kilometers. But notice how far away this is compares to the sizes. What I want you to remember, to think about, is that it's something like 30 different Earth diameters fit between the Earth and the moon. In other words, this, about the width of my thumb, is about one Earth on this scale. This is 2, 3, 4, 5, 6, 7, 8, 9, 10. So that's about 10 Earth diameters. Then this would be another 10 Earth diameters, and this would be another 10 Earth diameters. That's about 30 Earth diameters, 30 Earth diameters. There's about 30 Earth diameters between the Earth and the moon. Once in your mind you separate how far away the Earth and the moon are and how small the moon is compared to the Earth, then it makes understanding the phases of the moon much, much easier. All right, so when we ask a random person, draw me an Earth and a moon, they'll probably draw something like this. Of course, you can now see the scale is completely wrong. How far away do you think the Earth is from the sun? The Earth-Moon system from the sun? If I had you draw a similar picture, you would almost certainly draw it wrong because it's always much bigger in space than we think it is. And it's the same thing between the sun and the Earth-Moon system. It's important to understand the sun is practically infinitely far away from the point of view of what we see on the Earth there. How do I quantify this? Right? If I ask you to draw a picture of the sun, you'd probably draw something like this with an S. And if I asked you to draw the Earth-Moon system on the scale of this being the sun, you'd probably come over here and draw, I don't know, something like this and call it Earth, and then maybe you put a little dot right there and you call that the moon. I don't know, that looks about right. And you would say, okay, I think that's about right. That's pretty far. Sun is really, really big. Earth is much, much smaller. The moon is even smaller than that. That's really, really far away. No, 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 no. Your mental image is completely wrong. Let me show you how wrong it is. The distance between the Earth and the sun in actual units, the distance between the Earth and the sun is about 149,600,000 kilometers. Right? So don't forget, we said that the distance between the Earth and the moon was about just over 250,000 kilometers, not even 1 million kilometers. But the distance between the sun and the Earth, it's not 10 times that. It's not 100 times that. It's way more than that. It is 149 million kilometers compared to something much less than a million. The distance from the Earth to the moon being 384,000 kilometers, and the distance between the Earth-Moon system and the sun being 149 million kilometers simply boggles my mind. We just a minute ago said that how many Earth diameters are between here and here? It's about 30 Earth diameters that could fit between the Earth and the moon. How many Earth diameters do you think would fit between the sun and the Earth-Moon system? The answer is 11,750 Earth diameters fit between here. So you can see my picture was completely wrong, right? This is an Earth diameter. How many do you think I drew fit in here? Well, you'd have to fit 11,007, almost 12,000 Earth diameters between the sun and the Earth. See, the solar system and anything you talk about in space is just much, 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 much bigger than you think. No matter what you think, it's always bigger than that. So when we talk about the phases of the moon, I keep harping on this because you need to think about the sun being really, really, really far away with essentially parallel rays of light. Even though it's radiating in all directions, we're so far away they look like parallel rays of light coming to us. And then in our Earth-Moon system, the moon is not very close to Earth, like where it's just going to bump into it. The moon is really far away. It's 30 Earth diameters away. That's very important for the next phase of what we need to talk about. All right, now the next piece of information we need to really understand this is we need to think about the Earth rotating on its axis, and we also need to think about the moon going around the Earth. So the Earth, it rotates in 24 hours. 24 hours goes around one time, okay? But the moon orbits the Earth, it goes around the Earth, approximately every 27 days. So not anywhere close to an Earth day. In other words, you need to understand the concept that the moon does go around the Earth. So the moon is always going around the Earth. That is really what's leading to the different phases of the moon. But it's traveling it's taking almost a whole month to go all the way around the Earth. Whereas when we go to sleep at night and wake up the next day and go through one 24-hour cycle, the Earth has rotated one complete revolution. So as the Earth rotates once, the moon only moves a tiny bit in its orbit. So the next night, when we get up and look in the sky again, the moon at the same time of the nighttime is going to be in a slightly different location. And then if we go to sleep again and wake up the next day at the same time, let's say we go out at 7 p.m., the moon might be there. Then the next night we go at 7 p.m., the moon might be there. And then the next night at 7 p.m., the moon might be there. So every night at the same time, the moon is in a different location. That's because with one revolution of the planet, the moon only moves a tiny little bit. That's very important as well. All right, now we'd like to do a little bit of a demo to show how some of these phases come about. When we do this, remember, the sun is really far away, and the moon is also really far away from the Earth, much farther away than I can hold it with my hands here. Here is my moon, here is the Earth, and here is the sun, right? So what I'm going to do is step over here and ask you, what would you see if you were standing on this part of the Earth, and the sun is over here, right? So remember, it's daytime. And over here is the nighttime because the sun is illuminating here. Now remember, the sun is shining in all directions, but I have to use a flashlight. It makes for a better beam. So, of course, the light's going in all directions here. Now, if I put the moon between here, what does this look like? See, this face of the moon, this half of the moon is illuminated. No matter where the moon goes, even if it's over there, see, half of the moon is always illuminated. Even if it's on the other side, half of the moon is always illuminated here. Now, you might say, if the moon is over here and the sun is over here, then isn't the moon shaded by the Earth? Well, yes, we can have lunar eclipses occasionally. But what you need to remember is the sun is many thousands of Earth diameters that way. Remember, I told you that. The sun is not really right here on top of the Earth, and the moon is really not here on the other side, shadowed like this. Really, the sun is way that way, and the moon is way that way. So it's not going to shadow it like this, and that's why we don't have lunar eclipses every month, because the orbit of the moon is inclined to the Earth, and the alignment is not exact every month. Because the fact that the moon is much farther away and the sun is much farther away, the alignment to get an eclipse is not something that happens every month because they're not on top of each other like I have to hold them with my hand. So when I move the flashlight over here and illuminate it over here, you might think I'm cheating because the sun cannot be between the Earth and the moon, but just consider that the moon is way over there and the sun's way over here, and the rays are going essentially above and below the Earth and still illuminating the moon. Maybe the moon's a little up here, maybe it's a little bit down here. So when the sun rays are hitting this moon over here in the dead of night, it's illuminating half of the moon. We call that a full moon. Because on the nighttime side, if the sun is illuminating the daytime side here, this is the nighttime side over here. And then if the sun's rays are illuminating this, we see that as a full moon. If the sun instead is on this side here, then people on the day side of the Earth looking up into the sky, from their point of view, they're only going to see the shaded region on the back side right here. That's called a new moon. Another way to look at it is I look directly into the camera and you say you're on Earth and you're looking up in the sky. And I'm holding the sun right here. See, it's bright. And you guys are on Earth and here is the moon right here. And so I'm shining a light on to the moon here, but you really can't see it too well, right? Because the illuminated face of the moon is facing away from you. If you, being the camera, is on the Earth looking up, all you're seeing is the backside, which is essentially obscured by the bright light of the sun, and also you're not able to see it because the sun's on the other side, and so that is called a new moon, when we don't see the moon because it's basically buried in the sky with the sun, and we can't see that illuminated face. That's what we have in this situation. This is called a new moon. The only way you can see it is to look up and see the dark, shadowed side of the moon, and it's also very close to the sun in the sky, so it gets lost in the glare. On the other side, whenever the moon is directly opposite of the sun, it appears that the Earth is shading the sunlight, but as I mentioned a half dozen times by now, the sun's rays are still able to illuminate the moon on the other side because everything is spread very far apart, and then we see a full moon. So that covers the new moon and the full moon. And you can might imagine that all of the different crescents and gibbous and all of these things that happen in between the new and the full moon, that is just because you're seeing a sliver of the illuminated face. No matter where the moon is in the sky and how the sun is shining on the moon, the sunlight is always able to illuminate half of the moon's surface. I'm going to say that one more time. No matter where the moon is in the sky, no matter where the sun is in the sky, no matter where the earth is in the sky, the sun is always illuminating half of the moon. By definition, the sun's rays are always illuminating half. But in the situation where it's off at an angle like this, then from the ground, we're not able to see the fully illuminated face of the moon, and we only see a portion of it, and that is what we call crescent and gibbous and such. So let me turn off the light so we can see it just a little bit better. All right, so here we are again with the lights out. And so here we have a situation where the sun is illuminating the moon, but on the earth, from the earth's point of view, all you see is a shadowed, non-illuminated side of the moon. You don't really see it because when you look up during the day, the moon is very close to the sun in the sky, and so you can't see it, and it's also very dark as well, so you just don't even pay attention to it. We call that a new moon. Right? Now, if the moon is on the other side of the planet, again, it appears that it would be shadowed. If the alignment were exactly correct, this would produce a lunar eclipse, but eclipses are rare because everything is spread out so far that the alignment has to be perfect, and so the orbit of the moon is inclined, and so that alignment doesn't happen as often as you might think, because in our mind we think everything's close together, but in reality everything's very much spread apart. So in reality, even though the sun is here, and the earth is here, and the moon is here, and it looks like it's shadowed, in reality the moon is still illuminated because the sun is gigantic and the rays are going all the way around the earth and the moon is way far away and is still able to be illuminated. So during a full moon we see a situation like this. Now you can only see half of it illuminated because you're looking from that perspective, but if you were over here, again at nighttime, this is the daylight side of the earth, this is the nighttime side of the earth, and you would see a fully illuminated moon. So what happens in between? If the moon starts to go over here, you can see that from the ground point of view, you're going to start to see, so you can see no moon here, but as the moon moves over here, then you can actually start to see a portion of it illuminated. You can sort of see like a crescent, and as it goes around, you're going to be able to see more and more of the moon appear, and until eventually it is like a full moon over here, and then the process will then continue as it goes around the other side. That's about all I can do with the props. I want to take this down and I want to show you with graphics a little more detail exactly how the phases of the moon actually come about. I do have one more prop demo to show you, and we'll do it with the lights on and the lights off. It's a little bit different. What I want you to do is pretend that you are standing on the ground, you are on Earth, and you're looking out towards the sunset. So I'll put this image up, as you've seen many times, a crescent moon at sunset. So I want you to think about that image in your mind. You see the sun going down, you see the crescent moon hanging right above the horizon. All right, so now I want you to pretend that you're on Earth and you are looking at the horizon, you're looking at a beautiful sunset. And right here, this is the horizon line here. You gotta pretend this is the Earth, okay? So you're standing on the Earth and you're looking at the horizon line of the Earth. This is it right here. So this is the sun, and the sun, of course, is setting, so it's going down behind the horizon line. This is what this is right here, okay? Now, what we have is we have a situation with the moon. Let me move this out a little bit right here. Let's hover the moon above the horizon. Remember, the sun is not really right here. The sun is really far away, thousands of times farther away, right? Almost 150 million kilometers away. It's really far away. I have to hold it right here, but it's really far away that way, and the moon can be between the Earth and the sun. So let's say the moon is right here above the horizon and the sun starts to set. But the sun is shining in all directions. So you see what's happening is the sun is shining up towards the moon. It is set. It's 150 million kilometers away, but it's illuminating the moon, and from your point of view, you see a crescent. All right, let me turn the lights off so you can see it a little bit better. All right, once again, here is the sun. It is setting here. The moon is above, and the moon is always illuminated from below because the sun is setting here. And so what do you see? Of course, half of the moon is always illuminated, as it always is, but from your point of view, the half of the face of the moon is illuminated, but from your vantage point, you can only see a sliver of it, a crescent moon setting at sunset. All right, now I have a couple of different figures to help us understand the phases of the moon in a little more detail. Here's the first one. I think the next one after this one is even a little bit better. So here we have various phases of the moon numbered on top here. And then we have the sun here, and we have the Earth-Moon system. Now you know that the separation between the sun and the Earth-Moon system is really far away. And also the moon is really far away from the Earth, but it's never drawn like that. But you need to think about it in your head. Right? So as the sun illuminates the whole system, you see at all times the moon is illuminated. Half of the moon is always illuminated because it's a sphere and it's being illuminated by something really far away. So essentially parallel rays are illuminating one half of the moon at all times. But you see, If I'm standing on the surface of the Earth right here, let's say, let me take this off and use it as a pointer. Right here, let's say, and I look up in the sky, then if the moon is actually in this location and it's noon, what am I going to see? Well, the sun is going to be blinding me. I'm not going to see much of anything, but there is a moon in the sky. This face of it is illuminated, but the back side of it is going to be dark, so I'm not going to be able to see anything. And when finally the Earth rotates, because here's the other part you need to think about, it takes 27 days for this revolution to happen of the moon, but the Earth rotates in only 24 hours. So in one rotation, the moon just moves a little bit. Another rotation, the moon moves a little bit. Another rotation, another. So in 27 of these rotations, it finally goes all the way around. But in the course of one night or one day-night cycle, the moon is basically in the same place, pretty close, during one day-night cycle, moving just a little bit. So as the Earth rotates here, and the sunrise happens and the sunset happens, the moon is hanging in the sky in the same direction as the sun. We don't see it. We see the shadowed part, and it's buried in the glare, and we call it a new moon. But if the moon is over here at position 5, which is the full moon right here, what do we see? Well, the rays of the sun are illuminating the moon, and again, the scale is wrong. It looks like the Earth will shadow and all of this, but the moon is, let me remind you, the Earth and the moon are separated by a great distance. And the moon's orbit is not exactly aligned, so it can go above and below the plane of the orbit of the Earth around the sun. And the sun is many, millions of kilometers in the other direction. So everything is very much spread out. So there is no shadowing in everyday situations over here. So you have an illuminated face of the moon, and the dead of midnight, you're going to see the full moon right there. But at any given intermediate place, if I'm looking, if the moon has moved to this position, the same face of it is illuminated, right, over here. But when I look up, what am I going to see? I'm going to be able to see some of the dark side and just a tiny little bit of the illuminated section. Notice that when I look up, let's say from this location, I'm going to see mostly dark, but I'll start to see a little tiny bit of sliver of light down here. And then when the moon moves to this position, then I will again be able to see more and more and more of the illuminated area as the moon goes around. So I start to see more and more and more illumination until it reaches the full moon when it's back over here. And then when it reaches and goes past the full moon, it starts to go down the other way, because don't forget, this is nighttime side of the Earth. Over here, you can divide it in half. You could say this is the nighttime side and this is the daytime side of the Earth. So I see the full moon at night, right? And it starts to get lower and lower, because when I'm looking at it over here, I'm seeing mostly an illuminated moon, but I can start to see this shaded area that's not illuminated here, and so it looks more like this in position number 6. Eventually, position number 7, when I'm here, I can see about half of the moon there. And then position number 8, more of a crescent again. Think about it over here. If I'm looking over here, I'm almost always seeing darkness, but I can see a very small sliver of light right there, and eventually gets back to a new moon. This is a pretty good drawing if you can separate everything and stop trying to think of it as the Earth shadowing the moon or anything. You need to think of all this stuff spread out. And so the moon is very far away, and this side is illuminated, and then as I look around in the sky, I'm going to see different amounts of slivering of the moon as it goes through the phases. Now what I'd like to do is show you what I think is even a better drawing, because, you know, we all think differently, and I think differently than you, and you think differently than the next person, and sometimes a different drawing will help. Personally, I like this drawing a little bit better. So here we have a drawing where we have the sun here illuminating the Earth-Moon system, and we have different positions of the moon. The moon is going around the Earth. Notice that every little frame here, the moon is a little bit farther around the Earth, and then it gets back to its, very close to its starting position. So essentially this is like a 27-day kind of deal. Now notice it's not back to its exact position here, because to get to another full moon, it has to go a little bit past it, because the Earth has moved around the sun a little bit over the 27 days. So that's why it's not coming back around to exactly its same position. To get back to a new moon, it kind of has to overshoot, since we orbited the sun a little bit. We start at the new moon, we get bigger, 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 going through the crescent and the gibbous phase. Then we get to the full moon. Then we waning, then back to the new moon. So it's exactly the same information as on the previous drawing, but I think it's a little clearer, because what we can do is we can walk around in the different positions. Let's talk about the new moon and see what would happen. Now again, you need to think about the Earth during one day-night cycle is rotating. Sunrise happens here, when I can barely start to see the sun, this is the daylight side, and then the sunset happens when I get over here, and then this is the nighttime side. So I can draw a line through this, and I can call, this the nighttime side and this the daytime side. So morning is here and night is right here. All right. So what we have for the new moon is the moon rises and sets with the sun. Why is that? Because it's in the direction of the sun, and so as the Earth rotates, and I can barely start to see it, it's starting as the Earth rotates, and I can start to see the sun, then I can also start to see the moon rising as well as the Earth rotates, and the sun and the moon are more or less lined up. Now again, they're not lined up so perfectly in this drawing because remember, everything's really, really, really far apart. So these things are in pretty good alignment with the sun in real life because everything is stretched out. But what I see during the daytime is just the shadowed area of the moon. The illuminated side is completely facing away from me, so I don't see it, and I call it a new moon. Then we have the waxing crescent, whenever the illumination is getting a little bit bigger, and it's a tiny portion that's visible to us, and it grows daily. The illuminated portion grows daily as the moon orbits the Earth, and it carries the moon's daylight side into view. Unfortunately, the moon is drawn so close, it just looks like you're not going to see much, but the moon is really, really, really far away. And as soon as the sunrise happens, you may not immediately be able to see the moon, but eventually during the morning, you're going to start to be able to see the moon. And when you see it, you're going to see this mostly darkness of the moon, but with a very slight illuminated area there. And then as the month goes by and the moon moves into the first quarter area, then again, during the sunrise, you're not going to see any moon at all because the moon is way over here. The Earth is rotating. So as you come into view of the sun during the sunrise portion, the sun comes up and you don't see much. And then somewhere around here, maybe around noon or something like that, then you start to see the moon. And when you look at it and you see it, you basically see about half of it illuminated because again, the moon is not right on top of the Earth like this. The moon is really, really, really far away. So whenever you see it as it's drawn here, but it's not so close to the Earth like this. I mean, it appears that you wouldn't see anything up here, but really this whole thing is way moved over here. So when you look at it up here, you see half the moon. When you get into the nighttime phase, you still see half the moon, and so on. In the first quarter phase, the moon is going to rise somewhere near noon, and it's going to set somewhere near midnight because as the Earth rotates, see when the sun comes up, when the Earth, you're riding on the Earth here, when you get to here and you see the sunrise, you can't even see the moon. It's on the other side of the planet. But as you get to local noon, remember local noon is right around here when the sun is high, you can begin to see the moon and you see it illuminated in the first quarter situation. Then eventually the sun sets and you see the moon very high in the sky, again the first quarter moon, and then eventually the sun, as the Earth continues to rotate, you get down here so that the moon again sets and it goes down, but it goes down as a quarter moon like this. The moon moves position, and now it's not really visible very much during the daytime because it's on the other side of the planet. Notice the sun is still illuminating the moon. The Earth is not in the way. It's not shadowing the moon the way that you see it here. The moon and the Earth are really far away, so it's still illuminated. When it gets to nighttime, you see almost the entire full moon illuminated, but there's still a sliver of darkness that you can see on this side, and so you see it as a waxing gibbous like this. Eventually, halfway through the cycle, we get to the full moon situation where the moon gets completely on the other side of the Earth from the sun. And again, it looks like it would be shadowed here, but everything is very much spread out and the moon is still illuminated. It's so far away and not right on top of the Earth like this that it's not shadowed in general unless there's an eclipse and a special alignment. And you see this side fully illuminated, and then basically it's going to rise. The moon is going to rise right here at sunset, and then it's going to set right here at sunrise. Because if you imagine riding on the Earth and you're this marker and you're standing on the Earth, okay, here's sunrise. I can't see the moon because it's on the other side of the planet, but the Earth is rotating. Eventually the sun goes down. From my perspective, the sun is going down, but the moon is starting to come up because I can see it in this direction just as the sun is setting in the other direction. I can see it coming up, and when I look at it, I see it fully illuminated. It's not shadowed or off at an angle like this. The moon is really far away, and I see it half fully illuminated like this. Again, rising at sunset, around midnight is high in the sky, directly overhead, and then of course it sets right around the time of sunrise. And then we can continue to process all the way around. As the moon continues in its orbit, we get to the waning phases, where the illumination starts going down. Why is that? Well, this face is illuminated here, and as it gets closer and closer and closer back to the new moon, basically we're only seeing, again, we're fully illuminated here. I can start to see a little of this shadow. I can see a little bit more of this shadow. I can see a little bit more of this shadow. And then finally, I'm back to a new moon where all I see is the shadow. And again, the moon is in the same direction of the sun. And so I miss it anyway. All right, that is a long-winded way of saying that half of the moon is always illuminated. Always. It's just that as it moves around the planet, from our perspective, we only see different slivers. And the reason it goes from a new moon to a full moon and then back to a new moon again is because of what we've outlined here. Because when everything is in alignment, if the moon is in the direction of the sun, like it is right here, then two problems. I only have a darkened region that I can see from the Earth, and the moon is in the same direction of the sun, so I'm never looking at the sun, so I don't notice it, but it's up there. We call it a new moon. It sort of disappears, but it's still there, okay? And we have the same thing over here. And then the other way through the cycle, when the moon is on the other side of the planet, it's the exact opposite situation. It's fully illuminated, high in the sky. At nighttime, we call that a full moon. All right, now the last thing I want to talk to you about is something called earthshine. So let me show you this picture. This is the same crescent picture we looked at early. Notice that you can see the crescent. You can see the crescent moon, but you also notice the darkened area of the moon is not totally black. Now you might wonder, why is that? You would think that if the sun is illuminating the moon, and then everything that's not illuminated should be pitch black, like inky black. But when we look at the moon, we do see the crescent or the gibbous or whatever it is, but we often can see the non-illuminated portion of the moon if we look carefully, right? How is that possible? Well, what's going on here is notice we have the sun, it's hitting the moon, but it's also hitting the Earth. So let's go to like a crescent situation. This is a waning crescent like this, right? So we only see a tiny little sliver of crescent moon. We mostly have a darkness facing us here, and so we only see the situation. What's happening is the sun is also hitting the Earth, and sunlight, just like it reflects off the moon, it also reflects off the Earth. So when the sunlight bounces off the Earth, it hits the moon as almost like a mirror coming and hitting the Earth back into the moon, and it very dimly illuminates the moon with earthshine. So the reason we look at the crescent moon and the gibbous moon and we can still sort of see the darkened area of the moon, it's not totally black, is because sunlight is reflecting from Earth back into space and hitting the moon. So what you would think is inky black is not totally inky black because it's still illuminated a tiny bit from earthshine. Now, the very last thing I wanted to talk to you about before we close it out is the lunar calendar. Here's a lunar calendar. This is for this year, but it honestly doesn't matter. It's a generic kind of thing. You can see we have day number 1 all the way through day number 31 in a month. And then we have each of the months of the year, January through December, and we have this big lunar chart, right? Some people pay a lot of attention to this for various reasons. If you like to go fishing or something, maybe you pay attention to it. If you're into other things, you might pay attention to it. But it's just a chart showing us the phases of the moon. Notice what's going on here. If you start with January 1, right, this is just a little bit, almost a full moon. And the full moon was way over here. And then we are getting more and more and more dark, dark, dark. Here we have a new moon at this dot. And then we have a thin crescent getting bigger, 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 full moon. And then we have the crescent. And then we have, or I should say, this is the full moon. This is getting smaller and smaller, smaller and smaller and smaller. And then we have a thin crescent, and then we get to a new moon. And then we go back over here, and we're getting more and more illuminated back to a full moon again. So you see this process is happening over and over again. So you can look at a glance and see that the new moons are happening kind of on this diagonal here, and the full moons are happening kind of on this diagonal, the dots here. But notice they're not all lined up in an exact line, and you might ask, why is that? There's a couple of reasons for that. The moon orbits every 27 days around the Earth, but none of our months are 27 days, right? February is 28 days, but most of the months are 30 or 31 days. So that means it's not going to line up exactly, and it's going to be shifting a little bit each month. Notice the full moon is shifting backwards every month, but that's because the moon is orbiting in a little bit less time than 1 month, okay? And the second issue is something that we kind of talked about briefly here, and that is that as the moon goes through one of its 27-day cycles, the Earth actually has also moved a little bit. So over here, the new moon, the position of the new moon was when the moon was at this angle, but in order to get a new moon over here, it needs to be a little bit past where it was over here because the Earth itself has moved in its orbit around the sun. So there's two reasons it's not a straight line for the new moons and the full moons and just perfect grid like that. One of them is because the days of the month are all different, and so it's shifting. And the other is because as we go around the sun, the lunar positions that give you a new moon and a full moon are constantly changing a little bit as the angle with the sun changes also. I hope you've enjoyed this. I enjoy learning about the moon because one thing I'm confident of is that every human that has ever lived has looked up at that moon. So when I look up at the moon and I see it and the sun, I think, wow, Aristotle looked at that moon. Cleopatra looked at that moon. Whoever, pick your famous person, looked at that moon, and they wondered about that moon. And in 1,000 years ago, maybe even before language, several thousand years ago, people looked at that moon and they wondered, why did it change every night? Why is it different tonight? Does it mean something? Does it have a cosmic significance, right? And so when I look at it, I see a connection with humans that came before me. And so I wanted to share with you that we know now exactly how this worked because back in the ancient times, they had absolutely no idea how it worked. It was very scary because things change and they didn't know why they changed. And your brain always wants to know why, but you don't know why, so you usually give some supernatural reason for it. But now we know exactly why. Just because the moon goes around the Earth every 27 days, and the Earth is going around the sun as well, and the Earth is rotating on its axis, and we're looking at different slices of a moon that is always illuminated on one half from the sun, and also knowing that the sun is really far away, and the moon is actually really far away as well. Everything is spread out. That's how it leads to the phases of the moon.